Very nice to meet all of you, and thank you for hosting today. I'm Randy Johnson. I'm VP of Sales at Harvest, sometimes called Harvest Thermal, our previous brand, if you will. But we are a thermal storage management platform for HVAC and hot water solutions. I think it is going to fit very, very well into the passive house concept, and I'm excited to present to you guys today. Just a quick background on myself. I am about a year in with Harvest. But I've been in the climate technology space, kind of carbon solutions in the residential, world for about a decade now. Got my start in the solar and battery world. Worked in energy management for a while, but overall, I've been working with the trades for about 10 years, kind of bringing low carbon solutions to market, kind of with mostly focused on cutting edge, kind of emerging technologies. Brett, would you mind just making a quick introduction as well?
Yeah, absolutely. Nice to meet everyone here in this format. My name is Brett. I manage the California market for our direct sales. Been with Harvest for about 2.5 years. Previously with a company called Warmboard, selling radiant heating. You may know our territory manager out there. His name's Larry Smart. Did a lot of work in that market, so very familiar with the Colorado market. Just working with him. Looking forward to telling you guys more about this platform. It is an amazing feature that you can add to your projects that you're currently working on.
Thank you, Brett. Appreciate the introduction, and also share as well. I'm also based in Northern California. I'm out of sunny Sonoma County today, where it's getting quite warm outside, and my house is staying nice and cool with my harvest system. I also spent a good chunk of my 20s in the Front Range and up actually in the Vail Valley as well. So the Rocky Mountains have a very near and dear part of my heart. I do very much miss them, though I do enjoy California as well. And without further ado, we'll jump in. We'll talk a little bit about our technology. We're going to speak through some of the technical considerations around design, applications, limitations, all sorts of those kind of things. As you have questions that may come up, if you want to throw them in the chat, that's perfectly fine as well. We're going to do a kind of a deeper Q&A session at the end, but I want to kind of go through the applications to start with, and then we'll go from there. As all of you know, heat pumps are the champions of building electrification. They do come, with a little bit of limitations, though, and I want to talk through the context for why we developed this product. As you can see here on our graph, this is a day in the life of the grid, right? And obviously the grid shape, if you will, is different by market, by state, but the general gist, as you see in most markets, is that there's a whole lot of renewables on the grid in the middle of the day. It also happens to be when it's warmest outside, when heat pumps are most efficient. Now, the challenge that you see with scaling adoption of standard heat pumps is that they run when it's coldest outside and when the grid tends to be the dirtiest. And what I mean by that is typically you see the highest heating calls and hot water calls around between 5 and 8 in the morning, when it happens to be the coldest ambient temperature of the day as well, in that morning peak. And then obviously in the evening times, we typically see higher grid costs and emissions. And that tends to be when you have your evening peak for heat pumps when they run as well. Right? Now, what the Harvest platform is actually a smart controller. So essentially, we take an off-the-shelf, highly efficient heat pump water heater that creates water very, very efficiently at about 150 degrees Fahrenheit. It's a CO2 heat pump, so it's called a monoblock, so all the refrigerant is closed in it. Very low global warming potential refrigerant. That stores water in a thermally insulated and stratified tank. And we use that stored water to deploy both heating and hot water in the home through a hydronic coil, and integrated directly into the domestic hot water system. So Harvest, as the controller, if you will, the green box there in the middle, separation there, and we can actually charge that with as much thermal energy as we need to based on the heating load of the home, right? And so what the pod does, the Harvest pod, it learns the behavior and heating requirements in the home. There are calls for hot water, when do we take showers on a daily basis, what is the the temperature going to be, ambient temperature going to be tomorrow. So we learn the demand and predict the demand, and we optimize when heat pumps operate in order to um, reduce overall cost and drive the maximum efficiency of all of the heat pumps that are operating here. Now, you'll notice here that there's a lot of grayed out equipment here. We actually work with off the shelf kind of third party OEM equipment. So as standard air source heat pumps, any brand that you or your installer may like. The heat pump water heater that we work with is made by Sanko. Sanden, which is a Japanese company that has a big North American presence, been in the market for about 3 decades, tried, true, very, very dependable. Um, Ultimately, what that delivers for us compared to traditional heat pumps from an operating perspective is we're able to shift the gross majority of the electrical consumption and the heat pump operation to the middle of the day when renewables are abundant. The ambient air temperature is higher, which improves the coefficient performance of the heat pumps. And because we're actually scheduling when they run, it's not an on off call like you would normally have from a thermostat. We're actually running the heat pump for an extended period of time, which reduces stress on the condensers themselves and potentially has the opportunity to increase the lifespan of the equipment within the system itself. All of this would be for naught if customers didn't love us. We have a net promoter score of about 87% right now, which is one of the highest in the industry. I think the industry average is around 40%. A couple of awards that we've won as a company as well. And generally speaking, as folks are shifting from a natural gas or an oil-based heating solution, natural gas customers in California, our core market where the majority of our fleet is, save on average about 30% compared to gas, and anywhere from 20 to 35% compared to standard heat pumps as well, through our ability to shift heat pump operation to the warmest time of day. And also, I forgot to mention this, kind of an important piece, you'll see that the green line kind of bottoms out here around 4 p.m. Some of you folks might work in Excel territory as an example, which also has time of use rate structures where the rate actually climbs up in the afternoon. That's something that's also programmed into the harvest pod at the commissioning status. So we know what the rate structure is going to be and can therefore shift the operation to the lowest cost times of day as well. Let's take a look under the hood. So the harvest pod, the controller, it controls the amount of water that we keep in the battery, right? And what I mean by that is we only charge what we need to minimize thermal losses. So, right, based on our predictive algorithm that says we need, X therms of heating and X therms of domestic hot water for tomorrow, it's going to control when we run the heat pumps to charge exactly that amount, and we manage that and understand the state of charge in real time. Right. So it's going to predict what we need based on usage patterns. It also has the ability to evolve the algorithms based on real-time usage. So if it's Thanksgiving and you've got 8 cousins over taking showers all right in a sequence, it's going to start cranking out hot water right on point without missing a beat. We're going to optimize the heat pump's operation so they're most efficient, most cost-effective, and lowest emissions. Right? We're going to ruthlessly prioritize domestic hot water. We never want to run out of that. And we also have the very unique ability to remotely identify domestic hot water leaks, failure to start, power issues, check valves having something, particles stuck in it, things like that. So from an operational perspective, when we work with HVAC and plumbing contractors, we're able to serve up very, very valuable diagnostic information they're not able to get from any other platform on the market right now. So hugely valuable in that sense that they actually can understand what's potentially wrong with the system before they roll a truck to go repair it. A quick look under the hood here. Everything is factory assembled and pre-tested for quality, if you will. Everything is designed for field serviceability, right? So this is basically just a bunch of plumbing flow controls, thermistors and things like that. And then we have our electronics component on the left there. That's our board that controls and our connection to the cloud. Designed to be simple, field serviceable, and anyone with a basic plumbing background can actually swap out components in the field from something that you'd be able to either take off of a truck or buy at a plumbing supply house. From a design perspective, the pod is fairly compact. and ultimately designed to be stuck anywhere. We're looking to site that nearby our water tank, which we'll talk a little bit more from a design perspective here momentarily, but easy to tuck in anywhere. Um, and we have three primary applications. And I want to talk through these with a little bit of detail, but we'll actually go through and talk a bit more around design considerations. But I'm going to start in the middle. Harvest Classic was launched as a kind of a temperate weather heating solution, launched in the Bay Area, actually in Northern California. It is a hydronic heating and domestic hot water forced air solution, and it is highly efficient, very comfortable, and it provides heating loads up to 2 tons of peak load. So really wonderful for temperate climates. On the left side, Harvest Open is our most popular, most common configuration, and the most likely one for deployment, likely in the Rocky Mountains, just given the cold climate. Essentially, what we do is we take our load shifting hydronic heating and hot water solution, and we pair that with an air source heat pump that allows us to enable cooling, right, during the summer, and also provide a heating backup to the hydronic system on the coldest days of the year. I'm going to talk a little bit more about what kind of the logic and the design of that system will be momentarily here, but just understanding that that unlocks cooling for us and also allows us to do heating loads up to about 4 tons, right? So serving more homes in that sense. Lastly, we do have a radiant application as well. That's fairly common in the Rocky Mountain market. It allows us to basically add a thermal battery to traditional hydronic solutions like that. I will call it as well. This is a 150-degree water temperature from our heat pump. So we're looking at about 140 to 145 delivery after going through a flat plate heat exchanger. So the transfer material is actually quite important. We work very well with in-slab radiant and engineered solutions like Rother warm board. And so it's just very important to understand the comfort and transferability in the home. And we are starting to work on a radiator retrofit solution, testing that kind of in the field right now. We'll bring that to market here shortly. Ultimately, what that looks like is an ECM, like a fan coil application that allows us to do low temperature radiators, which is kind of important for the retrofit space, especially in the multifamily world. I want to just give you a quick glance of what the Harvest Open application looks like, because this is, from a design perspective, I think a little bit more complex to wrap your head around. But I think this diagram will actually help, even though it's a bit of an octopus here, help you basically understand the simplicity of it. We're essentially taking this off the shelf heat pump water heater. It is a split system, so there's a condenser outside, as you can see on the bottom right. We recommend minimum of 119 gallons of storage on a single family home. It's because we're using both space heating and domestic hot water all with a single storage tank. There are other configurations. We've got an 83-gallon tank, which we sometimes use for multifamily applications with a smaller heating load, or for a larger heating load, a bigger home, you can actually plumb two of those 83 gallons in series, which allows you to then get 166 gallons of thermal storage. So essentially a larger thermal battery with a longer runtime. Um, you'll see here in white on the right side our conventional DX heat pump. So this is a direct exchange third-party heat pump. It could be Mitsubishi, Fujitsu, whatever brand you prefer, your installer prefers, the homeowner might prefer. We work with anything off the shelf there. You're essentially selecting a pair, a condensing unit and an air handler, and then we actually stack our hydronic coil either in front of or behind. So that gets plumbed in series directly with the existing ducting or the new ducting that you're installing for it. We run hydronic lines that come up, and what we're able to do is the harvest pod will actually intercept the call for heating, and we will dispatch the most efficient and most cost-effective heating solution for this product. And what I mean by that is if we go back to a day in the life of the grid slide, right? If you remember that 6 a.m. morning peak when it's very cold outside, we actually tend to run off of the stored thermal energy in the battery, as it's not as efficient at 6 a.m. to run the heat pump. And so ultimately we'll pull off of the battery for a few hours in the morning to meet the morning heating load. And when that battery then gets depleted, Harvest System automatically would call for this DX heat pump to provide heating to the home. Well, the harvest system will allow the Sanko heat pump to recharge the thermal battery for that evening time peak once temperatures drop again and the rates go up. So ultimately, we're always optimizing for the best, the lowest cost, and the most efficient heating solution with Harvest Open. It's kind of how that system works together. I think at this point here, we're going to get very deep in the technical stuff, and just giving a timeline of the presentation here, I want to be really thoughtful around opening up for a Q&A session. So I think without further ado, I'm going to pause just right here on this slide, and if there are any open questions or any that have come in the chat, I'm happy to kind of dive through those. But we'll pause for just a minute here and open up the floor.
Hey there, I'm not seeing any questions in the chat. If you do have a question, please speak up. I guess one question I have about this is, are all three of these kind of columns of selection open and the other two classic? Do they all involve air handling units, and are these systems normally ducted?
The majority of the systems that we've deployed to date, Tyler, are inducted homes. That's not to say that this is our only application. It just happens to be the active markets in and the standard kind of heating, configuration that homes have. As a retrofit solution, that tends to be our most common option. We do have a growing number of radiant projects as well. And we're actually, Brett is in the process right now of deploying our first kind of radiator replacement retrofit in the Bay Area as well in an Eichler. So, ultimately, if we want to get into the technical details, right, typical boiler systems with radiators are designed to operate at between 170 and 180 degrees Fahrenheit. And with passive radiant radiators, right, typically you don't have enough heat transfer at lower temperatures in order to actually warm the building. And so we're deploying fan coils through a company called Campman, which is a German manufacturer that provides high efficiency, low temperature, fan assisted coils essentially as a full replacement in this Eichler, which I think originally, if I remember correctly, had in-slab radiant that had a breakage or a problem, and they had to ultimately deprecate that system. And so radiators were the replacement 20 years ago, and now they're looking to modernize and go to a heat pump.
Okay, cool. Another question I had was, the system is smart. It's taking a look at usage, and it's taking a look at time of use rates, but is it also taking a look at the outdoor air temperature?
Uh, Very, very good question. Very good observation as well. We have sensors on everything, right? That's part of having the system smart. And we do have outdoor air temperature as well. And so part of what it's doing when it's scheduling when the heat pump's going to operate. So you think about that Sanko 2 heat pump, when is it going to be most efficient tomorrow based on the weather forecast to run? And so we're always looking at that ambient temperature and trying to schedule the runtime to be most efficient, which ultimately, the shift from 6 a.m. to 10 a.m. is almost a point and a half of coefficient of performance on that system. And so ultimately it's a substantial daily reduction in the energy consumption than we can get even out of the Sanko system if it was dumb and didn't have the smart controls. So we're always looking both at the heating load, at the rate structure, and at the outdoor air temperature to optimize to all three of those. And from an order of operations perspective, Tyler, just to be very, very clear, our primary design and guiding principle in the algorithm is never run out of hot water. We think that that's pretty important from a consumer experience perspective. Number two is, run it most cost effectively. And so therefore the pricing inputs from the utility are very important. And the third is going to optimize for efficiency, which tends to also, coincide with low emissions as well.
Awesome, awesome. We do have a couple questions here. Debbie has her hand up. Go ahead, Debbie.
Hey, everybody. I'm a mechanical engineer, Southern California. Just wondering who coordinates the integration? Do you guys coordinate this with the HVAC, plumbers, whoever, or do you have the HVAC guy coordinate with you? Like, how do you put this all together? Because there's a lot of moving parts. Thank you.
Very good question, Debbie. And To answer your question, it's a little bit of all of the above, and it depends a little bit on the project itself. In a single family or kind of retrofit application, which is a big chunk of our business right now, we're mostly deployed through multi-trade mechanical contractors. So they have both plumbing and HVAC expertise, if you will. That's the majority of our contractor base right now that's deploying the product. As we get into more complex applications, say new build construction, passive houses you might be thinking of, or as we get into multifamily, typically we're working with either an MEP or architect, a designer in some capacity to kind of help coordinate. And what we provide as the OEM is kind of robust technical training and design assistance as well. So we have a really exceptional field operations team that's available to field questions from installers in the field from a troubleshooting perspective, but also to help us evaluate and make sure that we're speccing the system appropriately for the application. So all those services are available through Harvest.
Fantastic. Thank you.
Great. Kenneth had a good question here. He states, we have half our year here in northern Colorado is below freezing. Do you use antifreeze valve, direct resistance heat tape, or recirculation system to protect the Sanco 2 pump? And what about electrical outages in the winter?
Very good question on both of those. The Sanco 2 heat pump system is they have a cold climate variant that's available in Colorado. It operates and provides hot water down to -25, which is pretty incredible. It doesn't even derate till about -5 degrees, if I'm not mistaken. From a overall kind of design and resiliency perspective, Sanco 2 has redundancy in freeze protection. So there's two ways that they go about it. They do have electric resistive tape that goes around all the hydronic lines coming into the house. That is actually powered directly off the outdoor unit, so you don't actually have to run electrical for it. So it make it very, very easy to add that into a project. And then they also have mechanical drain valves that essentially, when they hit about 37 Fahrenheit, they automatically open up. And so these can be installed in the crawl space or exterior. They automatically open up a mechanical valve. There's no mechanism. It just opens up and it starts to drip hot water backwards out of the tank to prevent freezing. Right. So they have multiple layers of freeze protection. And then from a cold climate kind of a resiliency design perspective, so that would answer the question about what happens when the power goes out. That's essentially your solution there is that mechanical solution, the drip valves. From a design perspective, if we were looking at a radiant application, let's say in Colorado as an example, we would size this, in this situation for 30 kBtu an hour. We would do two stand-in outdoor units that are plumbed in parallel to provide us the output of about 30 kBtu an hour. And then depending on the overall heating load, if you're right near the edge, or for resiliency, we typically recommend an inline electric booster. So that would, basically run on a sensor and come off of the hot line coming out of the top of the tank. And that can run off, we just, I think, spec a Ream 7.6 kW, and that's ultimately 30 amp dipole breaker. It says the water is only 110 degrees coming out of the tank. That's not enough for our heating application. We're going to boost that up to 150 before it hits the heat plate exchanger. So lots of kind of different ways to design for resiliency in cold climates. That compared to an air source system, we're actually going to use the cold climate heat pump, which could be outfitted, depending on your level of desire for redundancy, could be outfitted with heat tape as a backup as well. We wouldn't need to back up the hydronic system on a forced air application because of that.
Great. Let's see. Todd has a question. What is the typical fully loaded cost of a new construction Harvest Open that includes the third-party heat pump or air handling unit? And if you're not able to include kind of that information, what is the cost of Harvest Open only?
I'll answer that in a few different ways because it does vary quite a bit by market, and there's huge variance within the market of mechanical contractors. We see for the Harvest Open system, we typically see installed cost before available incentives, which I'll talk about here in just a minute, of anywhere in like the $40,000 to $45,000 range on a retrofit application, right? So you're thinking a full rip out redo. It also depends on the ductwork and other things like that as well. And that's installed cost with labor included at market rate, roughly. Now, one of the unique things about Harvest that we haven't talked about yet, at least for the remainder of this year, is Harvest is a thermal storage system, right? So it uniquely qualifies for the 25D tax credit that's ending at the end of this year, which is 30% uncapped on the total project cost. And so, considering other incentives, local utility, Excel has outstanding heat pump incentives right now that can be up to almost $12,000 for an air source heat pump and heat pump water heater combined that we can stack. Um, California, similarly, we've got a $5,000 incentive on the table right now. Local CCAs, community choice aggregators, other kind of municipal utilities provide incentives as well. Most of our customers see installed costs in the mid to high 20,000s for heating, hot water, and cooling all combined, not including the heat delivery if it's a radiant application. So, ducted solution, if you would, all in. And if I may comment to that as well, what we typically see is first cost a little higher, but with available incentives, we're not only competitive with other heat pump products on the market, but we're getting to the point where we're competitive with even looking at legacy gas equipment, considering the cost of going in. And if you think about just the operating cost, we typically see almost an immediate ROI, if not within a couple of years.
Excellent. Kenneth has a question here. Is the mixing valve for the domestic hot water heater in the pod? And could the Harvest thermal pod work with a currently installed 89-gallon heat pump water heater capable of 165-degree operation for domestic hot water and air-to-air off-peak buffer storage assistance? Does that make sense there? It's in the chat here if it's good to reference. Or
I
you're welcome
think
to hop on too, Kenneth.
yep. I think I got most of that, Tyler. I may ask you to clarify the tail end. The short answer is that the mixing valve is in the pod, as you can see here, right in the middle there. That is adjustable. It's factory set at 125. The reason we need to have that in the pod is because we're making water at about 150 degrees, and that's way too hot for domestic water, but much better and more dense for the space heating application. So that's why that's built in there. With regard to the question around the retrofit of an existing heat pump water heater, the short answer is likely not. The reason being the core guiding principle about being able to manage the tank as a thermal battery involves very robust stratification. If we can't actually control the charge of that battery and the thermocline, we can't improve the efficiency, nor would we be able to necessarily have the interoperability to control the heat pump itself. So likely not with that application. Ours is a passive tank. It's also designed specifically, it's a 4-port, so there's too hot and too cold, bottom and top. And it diffuses the way it kind of injects water into the tank as well to prevent mixing. So the thermodynamics of the tank itself are actually very critical for our technology to be effective and to be able to increase the efficiency of the heat pump operation. Now, if you had a Senko 2 heat pump and tank, that's a different story because now we've already got the the infrastructure that we need to be able to do that. But that piece is very important. And from a future-looking perspective, we already interoperate with any kind of air source heat pump on the forced air side. So you can pick whatever brand you like. We're working towards a future where we're exploring kind of other heat pump variants and applications on the water side as well that will come to market here in the next year or so.
Great. I'm not seeing any other questions at this juncture.
I will, I don't want to put Brett on the spot there, but Brett, do you have any kind of closing thoughts? You know, you've been in the hydronic space for a while and even longer than I have. So maybe I'll call out, at least open the floor for you if you have any comments that you'd like to make.
Yeah, I think the only comment that I really want to touch on is more on the business side. This is very easy to integrate into your projects if they have the budget for a heat pump solution for domestic hot water. And of course, the HVAC side, whether that's a ducted solution or radiant, whatever that may be. We did actually sign the contract for that radiator pilot. So we will have data on that probably in the next month or two once we start seeing how that system is operating. Debbie, I think you said you were a mechanical engineer, very easy transition to either teach or get up to speed, HVAC subs or local subs that are working with heat pump technology. It's a very low learning curve. So I just wanted to touch on that side of it. Like this is something that you can feel comfortable positioning to your clients. It's a great value add to really extend the longevity of the equipment and save on energy for these clients more than anything else on the market. And of course, probably right in line with other solutions that they're already looking at. So just to kind of put a bow on everything that Randy was saying.
Right. Steve actually kind of there's a couple more questions that have come in the chat here that we should address. Steve is wondering if you could potentially work with a 40-gallon Sanko that's already installed with a radiant floor system in a passive house, so super low energy with 3,000 BTU heating load.
Steve, it's a super valid question. I would want to dig into that a little bit more with my technical team. The 43-gallon Sanko variant is a stratified tank. It is something that um, we've done a bit of kind of testing on, but we don't typically advise on because it typically doesn't have enough thermal capacity for the heating solution. So I would need to dig into that a little bit more. One thing that we could propose that would potentially be a pathway would be to replumb additional storage with that if that wasn't enough storage capacity. It's a fairly low heating load, which makes me think that there is potential for that. I guess my follow-on question for Steve is, does the Senko, is it just space heating or does that do domestic hot water as well? The way it's configured? Both.
Both.
Okay. Steve, I'd love to chat with you about that project. If we want to connect maybe offline, I'll drop my email address here in the chat.
Great. A couple more questions. Scott and Chris have some related questions. Scott is asking, does the cloud service require a subscription? And Chris is asking, can the unit function without an internet connection?
Both valid questions. Let's start with the first. Harvest is a one-time purchase. The cloud connection and support services that come with that are included for single-family homeowners. One thing that we are monetizing is the multifamily side of the business, because we're looking at a fleet dashboard that's actually we've developed this for our first couple of multifamily deployments. So there is an annual service fee on that on a per unit basis. It scales down substantially, but ultimately, we're highly confident that actually reduces operating costs for multifamily owners and asset developers because we're actually able to reduce your operating cost overall through that monitoring service and the value that it can serve. So no on single family, yes on multifamily. It varies based on the application, but there's no service fee for standard customers. Second question, I'm sorry I missed. Internet connection. Great. Also, so the Harvest Pod is designed to operate with a continuous internet connection. That all said, it's not required for it to operate. Okay. all of the algorithm data, all that kind of stuff does live locally in the pod as well as the cloud. What's very important from a connection perspective is in order for the system to be smart and to continually optimize and be prepared for the heating load, we need to know what the weather forecast is, right? And so that's actually it's a very simple thing input, and we're able to still operate if it was knocked offline for a few days, but um, continuous operation with a disconnect to the cloud would likely decrease performance over time. And so by design, it's intended to be connected, but it doesn't need to be connected in perpetuity all the time, if that makes sense. We just need those data inputs to be able to optimize the algorithm for the usage.
Great. Kenneth has a follow-up regarding the freeze protection system that's on the Sandco 2. Has it been field tested for power outages and other failure conditions?
Circo 2 is deployed in the North America, in all 50 states through a North American entity, but there are millions of them in the field, including their core market is Japan, which has very cold climates, and they've been field tested for decades actually. So there's a wealth of validation, if you will, on that product specifically. We have not done internal testing on their freeze protection. We've also never had any problem, provided it's done to spec. Now, if you don't insulate stuff correctly or you don't install stuff correctly, there certainly could be problems. The biggest challenge that we've had was, and it was actually in the Rockies as well. We had an installer just misdoing the insulation and the heat tape properly, and they had the circulator pump in the Sanko freeze and just had to be replaced. It's about $100 part, but more annoying for the consumer than anything else.
Great.
Yeah.
Well, excellent.
I'll jump in. That's the one thing that I've heard a lot here in Los Angeles with sustainability planning with the county. The folks near San Bernardino or wherever else that were snowed in, for a week. How do we tell them it's okay to electrify? Even the air conditioning folks. So they're the ones who voted no to requiring new appliances to be electric. And those are the folks that we really want to protect. And if we can convince them and ourselves and really believe it and know it's true, that would be wonderful.
You're referring to the South Coast Air Quality District ruling, Susie?
Yeah.
Is that correct? Yeah.
Mhm.
Yeah. Um, yeah, I think that's a super complicated a super complicated process, and from a policy perspective, and I don't want to go too far down that rabbit hole today, but I think there's a few things there that we can do. One of them is just being very education forward, right? A lot of working in this space is myth busting and educating on the capabilities and performance of technology, and kind of removing that stigma or fear about performance issues or resiliency issues that come from it. The similar ruling in the Bay Area Air Quality District goes into effect on January 1 in 2027, and we're already starting to see people scrambling on how to replace hydronic, combi systems and things like that as a result of it. I think the reality is that the market is demanding these solutions regardless of what the policy says. And I think that's true in the numbers as you look at heat pump adoption versus furnace and boiler adoption over the last few years. But yeah, I think my position is that being loud about capabilities and inclusive in our education and our outreach about these kind of technologies is a big piece of it, a big key of it. And then, continuing to leverage scale and speed through incentive programs that are designed to kind of accelerate adoption, which, I think California and Colorado, Susie, you being in Southern California, Brett and I are in Northern California, a lot of other folks in Colorado, two of the best states from a local and state and utility incentive perspective, really focused on moving this forward. And I think, and you'll notice that I could probably spin out about this all day. But the bigger piece here, as you look at this day in the life of the grid, the reality is that customers, from a cost perspective alone, right? I think part of the fear in the ruling with South Coast Air Quality District was, if we mandate electrification, does that drive costs up? Because the cost of electricity is very, very expensive, especially in the afternoon. And so I think the concern over user impact and cost increases, especially for vulnerable communities, is very real, and it's one of the things that we're trying to solve for at Harvest. And where I get really excited about what our technology can do, has the capability of doing for the future, is as an example, most time of use rate structures right now kick us with a high rate from 4 to 9 p.m. But when we see 10, 20, 30, 40, 50% heat pump adoption for heating, cooling, hot water, we're going to see a morning peak too. And we're going to see winter peaking. We're going to see all of these new kind of grid signals, pricing dynamics that have the possibility of actually increasing the energy cost burden for folks in their homes. And so Harvest has the unique ability. One of the reasons I'm so excited to be, deploying this product at scale, we have the ability to evolve and adapt to whatever the utility rate structure and cost paradigm is for said customer on an individual basis, and optimize for cost and efficiency from there. I think that's pretty powerful. And it's a really unique, technical capability for a heat pump company.